necessarily want to be a persistent, linkable
Right.
identity, but I still need it for security. I still need something as a security.
Sure. Sure. Yeah. Yeah. Those cases.
I'm watching the mobile driver's license space, like the
Yeah.
ISO standard for mobile driver's license,
Yep.
which is just a,
Yeah. Yeah.
so many ways I can go wrong.
Yeah. Okay. Let's get going. I think we can start. What is it on? Oh, here's someone. Okay, let's get going. Myself here first. Roman, you come. Yeah, you take it from there.
Hi, everyone. We're going to get started shortly with SecDispatch, but hi, I'm Roman Dinelli. I'm the Sec AD for SecDispatch with Paul Wooters. I just wanted, before we start, say you see a new face sitting up there at the mic. So Daniel Kahn-Gilmore, thank you so much for stepping up to help us lead and figure out where to take new Sec work. So appreciate your service.
Okay. Oh.
Thanks.
Okay, let's get going. This is not the note well. This governs everything that we do at the IETF. If you're not familiar with this, please make sure to familiarize with yourself with this. It's important. These are the IETF meeting tips. I think you probably already know what needs to be done here, so I'm going to skip those. Ground rules. SecDispatch, as you know, it doesn't adopt any documents, so we only recommend next steps. And there are potential outcomes. We could either direct the work to an existing work group, propose a new working group, AD sponsor a specific document, maybe decide that additional discussion is needed, or say that IETF should not work on this. So these are the potential outcomes. Before we go to the agenda, just an announcement about NOMCOM. NOMCOM just extended the feedback time until Friday. And if you're not familiar with NOMCOM, is the committee that selects the leaderships of the IETF. So it's critical that you guys provide feedback on the nominees that you interacted with. So please, if you have a chance this week, provide feedback to the NOMCOM. Okay, our agenda. So we switched the order a little bit because we have one co-author that needs to leave a little bit early. So we will start with expected sign mail with Daniel starting this discussion. After that, we'll talk about on-network path validation with Chan-Chi. And then the SAV document will be talking, Lindsay will be talking about that SAV document, okay? And we have enough time this time, like we allocated an hour and a half instead of that typical 1 hour. So we have plenty of time because we ran out of time, multiple meetings in the past. So that's what we have on the agenda. Any agenda bash, any comments? Yeah, yeah. And yeah, and thanks to Leif for taking notes for us. Thank you, Leif. Anything else? Okay. What is that? Okay.
So I am just taking off the hat I just put on. So this is just a piece of work that I started with Aaron Whistler and several other people actually. But Aaron and I are the ones with the names on the draft. So I'm presenting it here looking for where it should go or maybe nowhere at the IETF, which is about, that is the wrong draft. Did I upload the wrong thing? That's the wrong slides.
You did
I'm so sorry. That's a different slide deck.
Okay, hold on. Let me see if you have other. Do you know, sign mail?
No, expect that. I think I uploaded the wrong slides. So I can fix that, but maybe we can have somebody else go first. Aaron, I'm sorry if that screws up your schedule for needing to leave.
Okay,
Yeah,
Okay.
sorry about that.
that's fine. Okay, Peter. Oh, chin chin. Yeah, that's. Okay.
Hello, everyone. Welcome. Good afternoon. It's my pleasure to report this this new work we'll be doing. It's actually more of a problem space that we're kind of exploring. It's a problem that we're trying to explore. We're also trying to find a home, like what would be the best working group, or does this consists of a self-containing like a system, because it's somehow in between the security area and also the routing area. It's about running security. So here is that the general question is that should we like add more trustworthiness into the routing path and not just one routing network device. And in here we'll discuss the problem statement and what are the use cases. And please next slide. So we'll be talking about like why do we care about path validation, what it is. We want to disambiguate it. What are the use cases that currently we find more concrete? And we will propose a proof of transit solution based on the vector commitments. There was like an old solution to that, and we are proposing a more efficient, more secure way of doing it. And we'll be addressing a few feedbacks from past engagements. We have been discussing this from OPSEC from last IETF, and we'll be addressing feedbacks. And next slide, please. So in here, actually, the question is to add more trustworthiness into the routing path. So here, this is a funny story. Here, like, for example, James, he wants to make a phone call from overseas, reporting some, very high security level information, and he wants a really secured line. And for some reason, he kind of, maybe he's using VoIP, maybe he's just sending a message, but encryption for some degree that he thinks is not sufficient, because like encryption, we can have we can have vulnerable and outdated crypto, we can have cryptanalysis, we can have side channel attacks, although we cannot decrypt the information, but still we can have some extract some pattern out of it, and to know, like, for example, like an operation has just initiated, not knowing the exact information, but something like that. So next slide, please. So in this case, he may want to look for a dedicated line just for his information, for his transmission. And here he would like to request this kind of dedicated line. And Lady M will say that I can prepare this for you. I can plan this kind of routing path for you. But your connection should transit on top of it. So why should? You can have all this kind of a control plane paths planning and the remote attestation of those selecting those paths. But we actually don't know, we don't have such mechanism, or it's still in standardization phase, it's not mature, that how can we know the actual forwarding path? Does that align with what we plan in the control plane? So that's actually, we don't know what the actual path that is taken. We can only plan that. So basically, this is a gap between routing integrity and forwarding integrity. Next slide, please. So this, I think this may concern the security area, because it is about routing security. It's somewhere between routing and the security. In here, we're absolutely not fixing routing security once for all. We're just, giving one step forward. So the three-step recipe that we think that for secure routing is that number one is that we can select a path according to its trustworthiness, and we can securely propagate it. And the outcome is that every router holds a correct routing reference, for example, the routing table. And then you can have the router to be remote attested. It can be built on top of trusted hardware to make sure that it will execute correctly as we expected. But all those things that you can do is actually in the routing security. It's, you can actually only indirectly imply that the result should be correct. But you don't have a mechanism that can actually verify this, it is correct. So there's a gap in here because that we don't have like a proof of transit mechanism that directly verifies the forwarding result. Next slide, please. So what is path validation, you may ask? Here, I think in different contexts, people interpret path validation very differently. For example, in the security area, I just received an email that says, are you talking about certificate path validation? I say, no, it's far from it. It's routing path validation. So the routing path, it can be like two paths, both in the control plane path or in the forwarding plane path. And in the mostly in the BGP context, they do BGP-SEC, they do RPKI. It's more like a control plane path. But in here, like with more people concerned about the actual forwarding integrity, and they want to have some kind of trustworthiness or control over the path they are taking, some implementation is that the path validation could be to validate that what path that a packet actually traversed. So this later disambiguates into the proof of transit. But I think our understanding is that the path validation, in order to receive a desirable outcome, the control plane path and the data plane, the forwarding plane path should be consistent to each other. Next slide, please. So what are the current works that to fill this proof of transit gap? So there could be like telemetry. We can have IOM, in-situ OEM, to record the path of this kind of packet. But still, this relies on the reporting of a routers. So we still, if we want to have some secure telemetry, we will need some kind of secure mechanism that can securely log the trace of a path, of a packet. And the proof of transit works well. It can work for both underlay and virtual path, but still it has some, the previous solution that we find have some security drawback and have some computational overhead. And other works would be like path reconstruction, where like there will be a centralized controller that extracts all the routing tables from all the routers and to reconstruct this kind of routing path. But that's another way to indirectly verify the forwarding path. So the conclusion is that a common blocker in here is a general proof of transit solution, or maybe proof of transit solutions to different scenarios. Next slide, please. Generalizing the concept of path, we're reusing the draft the RFC 9473, how do they define path from the PNRG. So basically the path could be both a underlying path, underlay network path, or it could be like a virtual path that consists of virtual network functions. Next slide, please. So the core use case here is that we can do proof of service function processing. So for example, like some operators, they can host security functions, and their customers would like to choose like a bundle or package of those security functions. And then how can those operators prove to their customers that your packet, your traffic is actually processed by those security functions? So in this case, every packet, when it goes like through a firewall or a traffic filtering function, it will be best that it can have some proof of transit or proof of processing. In this way, this can be used for path audit or monitoring purposes, but mostly for third-party auditing. Next slide, please. There are also other use cases, and here those are some techniques that we find could be having some value add. For example, SFC, but also we can do perhaps WIMSI, because like WIMSI is a workflow that consists of containers or microservices. In this case, we have proof of transit. We can also prove that a workflow has been processed correctly by those containers in the sequence. And also segment routing, that's definitely because it features the source routing. And also IOM, definitely more accurate and trustworthy telemetry. Also ingress filtering, I think that's kind of interesting because when we have ingress filtering, we want to know that if a packet was coming from a right origin, it's not spoofing some other IP address. So currently when we have URPF, we actually look for, does a packet have a valid path back to his origin? And this path lookup is only done locally. So in this case, if we can do a proof of transit, we actually can, when a packet arrives, if it takes a proof of transit, we can just accept it. Otherwise, we can see somehow it's suspicious. Or the URPF, when it does this kind of lookup, there could be like this path is out of date. Could have leads to some false negative problems. And if we can do a reverse proof of transit, then we can have like a very frequent or in-time update of the URPF table. And also multipath and policy-based routing. When we have this kind of policy-based or routing, it still has a policy. We want to see if it complies with the policy that we set up. And multipath, when we have maybe 4 or 5 multipaths that are working all at the same time, we want to know which path it's actually using. So maybe when we have some earthquake or some natural disasters or other kind of disturbance, we can locate that which one of the path is actually not working, and we can switch to other working path very quickly. Next slide, please. So this is the solution that we're working on. It's actually using something what we call the vector commitment. It's another cryptographic primitive. So for people that are crypto savvy, vector commitment, Merkle tree is a vector commitment. But in this case, we're using some construction that's more efficient than Merkle tree. So in here, when you commit to a sequence of values, those values are attached to their indexes. And in here, each value in this vector is a router, represents a router. And we can, at the very first beginning, we can have the network controller to select this network path and commit it. And that means when we are actually forwarding this packet, each router would will do this opening proof. We'll prove that he is in the right position of the path that the controller has planned. So this relies on the position binding property of the vector commitment. The transit proof will only successfully pass verification if and only if it was created by the right node at the right position, and also as committed by the controller. And the advantage also of this work is that the transit proof creation only take constant time, and the verification also take constant time. That's very different from what we do, like when we use a Merkle proof that needs log n of time and auxiliary information. But in here, we only need one information, the constant, that is 24 bytes. And also we can do batch proof. Next slide, please. So also addressing feedbacks from prior engagements, we have talked about this in the OPSEC, and they have a few questions. Number one, what are the computing costs? We just demoed this in the hackathon of this time. Each router that, we do this as a proof of concept demo, but each simulated router, when they do this computing of transit proof, it takes about 1 to 2 milliseconds. And the extra cost of this transit proof added to the packet is 24 bytes. And the other question is like, maybe you can have some control over the exit router in order to prevent this, sending the packet to the wrong people at this very first beginning. And yes, that's a little bit out of scope, but I think that's part of the 3-step recipe for secure routing. And then the other one is that our work is actually a proof of transit solution. It's not a proof of non-transit solution. But basically, when we are dealing with the hardest routing security problems, we're actually dealing with the non-inclusion problems. Is it diverted to somewhere else? Is it copied and sent elsewhere, not going on this path. Right now, we have to clarify that this is a proof of transit solution, and a proof of non-transit is, if I can guess, is boldly, it's a non-deterministic polynomial problem. In non-inclusion proof is hard by nature, but also when we do this, like the proof of transit in a very large quantity, then we can actually probabilistically imply proof of non-transit. And also in the application, scenario, we think this is best first used in some limited domain where we have some control over the routers instead of absolutely none. I think in that case that we can at least have the trusted domain or semi-trusted domain have this kind of proof of transit. And when other domains think it's a good idea, they are doing their proof of transit, and we can connect those lines by the gateway between the ASs, and then we can have the inter-domain solution. But that's basically the next step. Next slide, please. Out of scopes, as we said, illegal data copy. Data is intangible by nature. If it copies, once you obtain it plain text, you basically have 100% control. You really can't help illegal data copy of the router. And the second, so that's why you kind of assume some kind of control over the trusted routers. Excuse me. And the stealth nodes, for example, like if the data is transmitted elsewhere using transparent channels, or if we're using some other old devices just forwarding and they are not computing this transit proof, then how do we do? Basically, this is not something that we can do right now because like layer design actually, by definition, they want us not to perceive those kind of transparent stuff. And I think it does make sense. I think it does make sense when we look at this level and not to look at the next level. For the next level, I think it needs different solutions. Next slide, please. Also, how does it, actually I'll conclude this very quickly. So how does this compatible to the current stateless hop-by-hop destination-based routing, AKA our internet right now? So how can we do this in the environment that we don't have control over the router whatsoever? I think the best starting case will be using a limited domain. That's for truth. And maybe when this becomes, well, some of our clients think this is a good idea, we can have some kind of proof better than nothing. And then other domains are trying to adopt this kind of way of doing it. We can connect the lines and have inter-domain solutions. And also other control over numbers, that's 5 and 6. And the number 7 is that we keep some traffic inside of a controlled domain. For example, like some jurisdictions, they will have the data sovereignty problem. They don't want their data to be flowed outside of their jurisdictions. It could be like a use case, basically routing compliance. And number 8 is that SFC processing proof is a social problem. Well, it is, but still can give some kind of proof solution from the technical perspective. And this can help the audit of the service provider as a way. Where the throughput, well, the stress test is under development. And I think it's best implemented in those software-defined forwarding, based on general purpose hardware. I think it's because it uses elliptic curve, a very special type, pairing-friendly elliptic curve. Well, implementing this on the ASEC chips would be kind of expensive. So using this in SFC or other software-defined forwarding will be better. And I think that's all. Next slide. Yeah, so this basically means that if we have no control over this domain whatsoever, then maybe it's hard. But if we can have those green routers somehow trusted or remotely attested, we can kind of extend the trust, and they don't have this intention of doing anything bad. We can do this by monitoring misconfigurations or error forwarding for this case. Best starting from limited domain. That's the conclusion. And next slide, please. Next step. POC is done. It's demoed in the 118 hackathon. I should have pasted a GitHub repository here, but you can find a GitHub repository in the hackathon slide. And the spec document is still writing. We have this problem statement document. And also we find few people that are very interested in the same problem. That is to add trustworthiness to the path and extend it from just one router to a path. And how can we select and attest to this kind of trustworthy path? And how can we verify if it's forwarded accordingly? Thank you.
Thanks, Peter. Richard.
Hi, so thanks for the presentation. And I want to appreciate especially the clarity you had, I think, about midway through about what use cases you're trying to do. And in particular, that you are not trying to prove that a packet does not transit a certain network. It seems to me, though, that like that's in tension with your James Bond example at the beginning and with your controversial use case at the end. So it seems like if we're going to do any work here, we should be really clear that proving that a packet did not transit something undesirable is really out of scope, and really all we're trying to prove here is that it did transit certain things. So that's a comment. And the question I had for you is, obviously this is verifying that a packet transited certain points and not saying anything about what's between those points. Kind of goes to the previous point. And so there's potential that there could be untrusted parties in between the trusted points. And so what I'm wondering is, you didn't talk much about protocol, but presumably there's something that is added to a packet here. And so what I'm wondering is what this protocol would reveal to those untrusted parties that might be lurking in between the trusted parties.
Yes. So maybe this is more like a link between like the two routers. So some people also recommended using something like MACsec to protect the links between those routing nodes. I think that's definitely a next step, but currently we're talking about like a general solution for that. And thank you for the comment.
But if I could just follow up on that though, like I don't think that there's anything you can do cryptographically that would prove that the physics of the world have that shape, that the endpoints of the two trusted things that are adjacent in this path were physically directly connected. So they're always going to, even if they're physically directly connected, right? As you point out, you might have MAC level or PHY level attackers. Like there's always going to be a possibility that there's untrusted parties between the trusted parties. So I think we do need to track, what's being revealed by adding stuff to these packets.
Hi, I'm going to do AD kind of override. When we're at the mic, can we also make sure we talk about the dispatch result we would like in addition to kind of figuring out the solution?
Yeah. Thanks.
Yeah, so let me formulate that. I think I don't quite have a hard opinion on that yet. I feel like this needs this feels like it needs some interdomain, inter-area reviews. So I'm kind of inclined to think that this might need a BOF as opposed to going along some faster path. And I think it needs a little bit more clarity along the lines I mentioned.
It was really difficult to get that last part, Richard. What's your thinking of that dispatch part? Richard?
So Richard said he's feeling like BOF. I don't know if it's different in the room from up here on the chairs, but from here, we're hearing a lot of echo from the remote voice. Does it work clearly for folks in the audience?
Okay.
It's good in the audience. Okay, so it's just up here. Okay.
And yeah, BOF, I think BOF, if anything, was my feedback.
Okay.
Thank you.
Thanks. Jeffrey?
Hi, Jeffrey Haas. Peter and I had a nice conversation earlier this week. Thank you for addressing a lot of the comments that had brought up in 117. You clearly addressed these inside of the draft in your presentation, and I think that's a clear win over what we had before. Richard made many of the points that I would otherwise make about a lot of the cases that are interesting, effectively fall under the proof of non-transit, or as the two of us have discussed, this mechanism provides no way to attest to transitive trust. So I find a lot of the use cases that have been put up as sort of on the weak side of things. There is one, though, that I actually thought stood out, reframing one of your points. You were talking about URPF BCP38 type things. That was the context you put it in. A thing that this can be useful for is preventing spoofing, specifically for these packets. This gives you the ability to say that only the routers that are expected to do it, if you have that as an end-to-end vector, those are the only routers that could have actually injected things, and therefore the injection and attack points, as long as they're not allowing a generalized injection and forwarding, are the only parties that could have done this. And for certain types of secured environments where non-spoofing is critical, that might actually be a use case that has some teeth to it.
Does that help you think about where to dispatch this to?
It for my use case, or sorry, this is not my use case. For the use case in discussion, I think that there needs to be iteration to refine what this should be used for. There's an awful lot of what this is not useful for, and I think that that needs to be expanded. I think that eventually where this ends up is probably int, specifically because that's where you do BCP38 style work. Because this is a forwarding operation, it very likely has some interaction with a programming protocol to put in all of these necessary bits of elements to do the path validation. But that's signaling that could be routing, that could be done somewhere else as well.
Okay, thanks. Ben?
Hi. So as I think about this, I think that I don't really buy the security argument here, and I think there may be something valuable here worth moving forward with, but I don't think it's a security question. The reason I feel that way is I can see two scenarios. One is that I trust the specific path components that I've named. I trust all of them and specifically what I trust them with is to operate according to some local policy and to secure their link to the next trusted endpoint. So if I have that level of trust, if I don't have that level of trust, then this doesn't work. It doesn't accomplish anything because an attacker could just swoop in and vacuum up a copy of all the traffic that I'm sending, or inject new traffic potentially. So that's one angle that. Sorry, let me rescind that. No, they can't inject, but they can make duplicates of all of this traffic and analyze it however they like. And if I do have that level of trust in all of these routers, then I don't need the path validation because it's sufficient for me to trust the first router and provide it with the instructions on the rest of the route, which it can then transitively pass down the route. The only way that fails is if I don't trust the routers, in which case the solution doesn't work. So I don't think it's a security system that meaningfully. I do think that it has potential for detecting misconfigurations in cases where all the parties trust each other and there isn't a threat actor at all, but there is the potential for just errors and accidental misrouting. And in that context, it would be good to have some way to check. And so my dispatch idea based on that would be something like Spring, an operational or routing-oriented group that's focused on path routing. And so the question is, how do we confirm that the path routing is really working?
Sorry, to add just one explanation for that. So like RAS, when we have, this could be like an extension to RAS work. Like for now, that we are actually trying to have some trust over testing the router or network devices. And then maybe, well, this is an immature idea, but I think maybe this could be like extending from just one device and then extending to a testing or to a path. So that's could be somehow SEC related, but definitely I would agree that it's it's more related to our routing or ops.
Yeah, even in a remote attestation case, I think it remains true that that I can simply pass the path description to the first router, verify via remote attestation that it is functioning correctly, and it can recursively validate the rest of the path rather than needing to do this data plane marking all the way along the path.
I think one more time.
So Richard, I see you're in the queue after we close it. Do you have a dispatch answer that you want to clarify your dispatch answer? So far, we've heard 3 different dispatch answers. We don't seem to be converging.
Yeah, and I think the other feedback kind of demonstrated why I thought a BOF was salient, right? Because we've had cross area assignments mooted as possible dispatches. So clearly it seems like we need folks with expertise from multiple areas with eyes on this. I would have some concerns about putting this purely in, say, the routing area, because there is some non-trivial cryptography here that needs some folks with some deeper cryptographic expertise. But I sympathize also, there's some routing internals. So it's a tough one. So this is kind of underscores why I think there's a BOF needed if we're going to do anything here.
Okay. Okay. We think there is probably need for more discussion to be able to really make a decision on where to dispatch it, because we've heard different ideas and different directions. So let's.
I think so. We can talk with you more afterwards to try to figure this out. I think one of the concerns that why people are pushing this in different directions is because the stated goal seems to be different from what the deliverables might be, and figuring out what the actual goal is more clearly, like what would happen when there's a negative result. For example, you get a packet, you find that the packet doesn't have a signed path. That might clarify what sort of security or routing goals you actually have for the document, which might help us to land it somewhere more clearly.
Yes. There are certainly some great questions that we don't have great answers currently right now. So that's why we're having this path validation site meeting tomorrow, Tuesday evening, and 6:30 p.m. And we welcome Mara to have a look.
And on the side meeting wiki, is there an option for remote access as well?
Yes, and I have a GitHub repository for all the materials and agenda there.
Okay.
Thank you.
So if folks have thoughts about this, if you stew on this and you want to come to the side meeting tomorrow to recommend new routes, then hopefully you can bring that back to SECDISPATCH too.
I was going to recommend that if there are any results or some consensus around things that come out of that side meeting, feel free to drop those on the SECDISPATCH mailing list, because that may also steer the way ahead.
I think my slides are fixed now. Can you refresh this?
Is the old one?
Yeah, that's the old one. It's new on the new thing. Here, I can display it.
Yeah, just no, just refresh it.
I already refreshed it and it worked. So is this being displayed?
Hold on.
Here, I can offer them.
No, I did refresh. Hold on. Let's see.
That one there.
Is it that one?
Nope. I'm going to share it here. And
Can you?
Yeah, I'll have you.
Okay.
Wait. Wrong button. You guys get to see all the errors. I clicked refresh and it didn't refresh. Okay. I can share a screen. How about that?
Let me try to refresh Is this the one?
Yes, that's it.
Hold on.
I just put it up
Oh,
there.
you put it. Okay.
Yeah.
Yeah.
You
Okay.
can just use the
Okay.
Jonathan up there.
Okay.
Is that okay?
Yep.
Sorry. Hi, folks. So my chair hat is off now. Apologies for the confusion. So this is a draft about end-to-end encrypted email. Sorry, not encrypted, but cryptographically signed email. So someone is sending a message to somebody else, they can sign that message. That works today, and the problem is it's not clear the advantages. So next slide, please. I would do page down. Okay. So we've been able to do this for decades. Not many people actually do end-to-end signing of their mail, and it's not clear that it is useful. It's not clear what you do when you get assigned mail that you would do differently if you got an unsigned mail. So next slide. So in theory, we might want to sign our mail because we want to assure the recipient that the mail came from us. Conversely, we might want to say that to the recipient, when you get a mail from me, you should look for a signature so that you can avoid being spearphished. Nobody can impersonate me and send mail to you. And you might want to do that in an end-to-end way to ensure that the recipient can tell what's going on. Next message. In practice, people don't actually send signed mail, even when they're capable of doing it, because A, it is a pain to do, B, it has ugly failure modes, and C, signing message A doesn't actually prevent spear phishing if message B that comes through unsigned doesn't give any kind of a warning. So there's this sort of collection of use cases that make it so that the goal of sending signed mail doesn't actually match up with the fact of sending signed mail. Next slide, please. These problems result, there are user experience problems, and we don't typically do that very well here, but that's also, the user experience is terrible because the mechanisms we offer aren't great. And I think there may be some mechanisms we can offer that user experience people could pick up later. Next slide. So today, this is an example of mail client today. These are 3 messages. One of them on the left has not been signed at all, and we see the message. The one in the middle is one that has a broken signature on it, and the one that's on the right has a valid signature on it. And you can see the difference in the little open PGP with the red triangle and the green check mark. I see someone trying to zoom in on the screen. It doesn't work from there. I'm sorry. This is terrible. This actually doesn't actually help people, right? And you could do different, I'm not trying to bag on this particular mail user agent interface, but this is not uncommon. One argument could be that the size of the security display is not related to its importance. But aside from that, I think the most troubling part here is that when you send signed mail and it gets broken in transit, it looks worse than if you had not sent signed mail in the first place. Right? So if an attacker wanted to send a spoofed message, they're not going to spoof the signature. They're just going to send an unsigned mail. And they'll get the less scary thing than if you go ahead and you sign every one of your messages and something breaks in transit, some of your messages are going to show up with a big hairy warning and other ones will show up with the green mark. But now the user is going to get this scary warning just because you had signed the mail. So next slide. This is broken, I think, because okay, so we've seen this situation before, right? So we've all browsed the web and you have a clear text website, an HTTP website, and in the past, an HTTP website just showed you in the browser bar the address of the website you were on, the name of the website. And you went and visited a secure website, you got a green mark. And if you went to a TLS, an HTTPS website that actually had a configuration problem, you would be blocked. You can't visit this website. And we actually had in the past, people say, I don't want to turn TLS on for my website because if I do, my users will get locked out of it, right? We had that problem in the past. We don't have it anymore. And the browser indicators, this is from a Chrome blog post from a while back, they went from initially, when you were connected securely, there would be the green lock, and then it went to there just being a lock. And the goal is we get it so that the normal state is no indicator. And then the failed state, when you have clear text HTTP, one more slide, please, would be a warning indicator, right? So we're not even there yet with HTTP, so maybe it's a little bit premature to be talking about this with other contexts, but at least today, you get a warning when it's broken HTTPS, and you get a warning when it's clear text. So that transition made me think, what can we do for mail that would have a similar effect? Now, granted, this TLS stuff is all about confidentiality. The mail that we're talking about here is just about signatures, but I want to think through the same logic about user experience. Next slide. Sorry, to keep on HTTP just for a second, one of the parts of that fix for HTTP was this idea that that a website could ratchet itself in and say, hey, if you ever try to visit me in the clear, there's a problem. You should switch to the secured form. And that was secure transport security, strict transport security, and that has been part of the shift to actually protect the web as well as it is today. So, and the client will refuse to make a connection to the server if the server has previously indicated that it wants to be strict about it, right? Because it used to be the case that you could stick a clear text HTTP proxy in front of the HTTPS website, and as long as the user went to port 80, you would just relay that over HTTPS and you'd still read the content and it wouldn't show any warnings. That's fixed today because the clients will refuse to load it in the clear. Next slide. So if you look at this draft that's in the LAMPS working group, the end-to-end mail guidance, it says it wants to fix one of the pieces at the moment, which says if you have a broken signature, don't display anything different than you would display for a missing signature. And I think that guidance that's in that draft right now, that hopefully will be moved out of working group last call. I think that's reasonable guidance because that means that at least if you're sending signed mail, you can go ahead and sign all your messages and you won't get scary things as a result of sending signed messages. There still isn't a great distinction between the signed and the unsigned, but at least the act of signing is less likely to get you a warning on the recipient side. This guidance is not universally implemented, as you saw in the screenshots. Next slide, please. I think we can go one step better, modeled on the strict transport security approach. As a user, you should be able to signal that the recipient should expect all mails from you to be signed, so that now you can reintroduce the warning, and the warning happens for all mails, whether there's a missing signature or a broken signature. If you look at the end-to-end mail guidance draft as well, it has an appendix of future work, things we don't know how to solve. One section of that, it says, we need to think about how we model the expectations of cryptographic protections for a given email. And so this is one piece of solving that, right? At the moment, the problem is the user has no expectations, the recipient has no expectations about what should be displayed. Next slide, about whether the incoming message should have been signed or not. So there's this draft. It says it has to make a bunch of decisions about how you do this. This is a list of the kinds of decisions that a draft like this needs to make. This draft makes some decisions, but they could be made other ways. And I want to figure out where we do this work at the IETF. So should the message be in the email header? That's what the draft currently does. It depends on there actually being cryptographically protected headers, because you wouldn't want somebody to be able to signal this without cryptographic protection. There's a question about how wide should the scope be? Do I send a signed message on a mailing list? Should it look signed? If it goes through a mailing list, what specifically, how does the user decide whether to turn the signal on, right? If I have two mail user agents and one can sign and one can't, if I turn it on user agent A, what happens to user agent B? There's a bunch of questions for how we do this in a reliable way. We should think through those questions. I'd also like working group help to think through how we undo this, right? Maybe you turn it on and you find out it's not working for you. Do you turn it off? How do you turn it off? What happens to the users who receive it? And does it say anything about what kind of signature is there? Is it always a signature from a given key? What happens if you change your keys, for example? Next slide. So the question is the dispatch question here. Aaron, I don't know if you have anything else that you think I should add in terms of talking through the problem space. It seems like LAMPS, because at least LAMPS was handling the E2E mail guidance draft through now, but it's also might be considered out of scope of LAMPS. If folks have other suggestions, I'd be happy to hear it.
Go ahead.
Phil Baker. Yeah, actually, originally it was worse. When S-MIME first started, if you sent an S-MIME signed message, there was a box that would come up on one of the large clients. Warning, This message is signed.
Right, okay.
And that is one of the reasons that we couldn't use S-MIME or anything like it in remediating phishing.
Yep.
Because, one of the big banks said, well, we can't do that. We've tested it.
And it's terrible.
Yeah, 5% of the clients did that. So I think it's really good stuff to go through. I think that LAMPS is the place to dispatch it to, because you want to have a sufficiently large community that are aware of these issues. And I think that LAMPS is the best place to find those. That said, I'm really leery about trying to fix SMTP mail and graft security onto it.
So your theory is we shouldn't fix SMTP?
No, I think that we should try, but we shouldn't be disappointed when we fail. I think that trying is good because we will get hold of the real requirements for doing it better and doing it right next time round. But
on the next internet, you mean?
No, on the net. I mean, people are already using Slack for messaging inside organizations. They're using Discord. They're using Signal. They're using Wire. SMTP is dying as business commerce. And I think that there's going to be a real demand for an internal, intra-enterprise mail system. And if we put one on the table that is interoperable between enterprises, it can do that and then span to be the next replacement for SMTP.
Okay, that's a little beyond the dispatch question, I think, but
Yeah.
I admire your vision.
Paul.
Hi, Paul Wouters, and I'm speaking purely as an individual here, which is a little weird, and my apologies. But I didn't see a big lineup, so I figured I wanted to get my voice in as an individual. There isn't very much security-specific protocol designing here. You are mostly talking about how to transport certain signals and how to deal with applications and UIs. And really, that is a quite different area than security. That's really more the art area.
Is there a particular working group that within art area who you think could handle this?
Is Murray in the room? No.
Yeah, so I asked the RADs this question, so Romanilio Karasakidi. They unfortunately told me they currently do not have a working group to catch email headers, assuming this is kind of where we had, in the generic case, there are multiple email working groups, but not with kind of this being kind of in scope, and it's unlikely it would be in scope. But there is constant talk in art that, boy, we really need one because we're AD sponsoring all of those documents. So the way I was told this is handled is it goes to Art Dispatch, and there's a conversation.
Ted Hardy, confirming voice on that, because at a dispatch earlier today, we had exactly one of these things where people said, gosh, it would be nice if we had a long-lived email working group to catch these things. First, a question. Have you talked to MOG about this?
I've not talked to MOG.
So,
because MOG tends to provide security mechanisms at the provider layer.
Agreed.
And this is about end-to-end. This is about an end-to-end promise that the message will be signed by the sender, not
okay,
the
I
sender.
wasn't suggesting dispatching it to MOG, trust me.
No, I mean, it's an option. I just hadn't thought about it there.
But what I do think might be valuable is actually running a BOF on this. And explicitly, because you would get both security and application folks who deal with both email and other forms of messaging at a BOF. And we would then be able to send over to the bits of MOG that do UE design questions, notice of the BOF. And I do think that there are some tricky bits to this, right? Although not common, it is still part of the standard to allow somebody to have mailbox plus suffix as a valid way of routing mail within their own reception. And if you wanted to have a different answer, I expect mail from this person to come to TED plus IETF at example.com. And for that, I want this. And for TED plus anything else, I want them to be treated some other way as not expecting signed mail, you get into some corner cases very, very quickly. So I think you might actually want a BOF to bring together the communities of interest if LAMPS isn't willing just to say, we're going to take it and we'll send notes to everybody to turn up.
Thanks.
You're on.
Johan Scheffer. The one word I didn't hear is encrypted mail. I think people care most, like real people care a lot more about confidentiality than integrity protection. And so my comment is mostly about messaging of how you present this work. It may eventually affect scope a little bit, probably not. I'm not 100% sure, but I really urge you to include it, since this is mostly about security usability. I think we need to think about encryption as well.
Okay, I deliberately kept this away from encryption because I think the semantics of encryption are very different from the semantics of signing, right? It's not that we have separate work about how do we handle encrypted mail, but in this case, the signing originates at the sender, and you would bind it to the sender. And I think it gets very confusing to add it to the encrypted stuff. If you're interested in questions about expectations of encryption, I encourage you to come to LAMPS, because there is some discussion going on there about certain kinds of expectations of encryption. In particular, the clear text copy work I'd like to revive at LAMPS, which came up at SecDispatch 2 SecDispatches ago. But I think that's distinct, and I think mixing them together would actually muddy the waters rather than clarify them.
Okay, I sort of expected encryption to come for free once you have this solution, but may have been naive.
Yeah, I think it's more complicated than that, unfortunately.
Any thoughts about dispatching it, Yaron?
A BOF for sure.
Okay. Thanks.
So I'm Deb Cooley-Ennis. I'm not wearing my badge, I'm sorry. So I sign all of my messages because I can, and I do. But the problem is, if I sign a message and send it to you, anybody in between me and you that modifies the bits on the wire means that you get a broken signature.
Right.
So it's tricky, right? So we call that molesting the emails.
Okay.
And we used to get broken signatures all the time because the servers would molest the emails. And so we got them to stop doing that. It's kind of fun. Exactly right. But it can occur anytime. Anybody clicks the little cookie button and whatever, and all of a sudden you now have broken signatures everywhere.
Yep.
So it's not really within the control of the sender nor of the recipient. So you can talk about UI all day, but anybody flipping bits in between can means it's broken. And the question is, in that case, do you trust the message? Do you toss the message on the floor, or do you still read it?
Well, you don't know what bits have been broken, right?
No, you have no idea.
Right. So
Fantastic.
there are a few. There's actually an expired internet draft that tried to document the common ways that messages can be broken. Again, I think this is a different discussion. One approach is to catalog the common molestations, and if they are invertible, your recipient client can experiment with inverting them and see whether the message signature is correct, and if it is, you can correct the signature. But I think that's out of scope for this. The idea with this is, if we can say, I want to encourage people to show broken signatures exactly the way that you show missing signatures. And people will say, well, I want to get a warning if my message was tampered with. Well, if you want a warning, the user needs to know that the message should have been signed. And the only way for the user to know that is if there is some sort of signal that says, expect a signature from me. And this is proposing that we do this at the sender level, not at the domain level. Maybe there's another argument for how to do it at the domain level. But if you can say broken signatures are equivalent to and should be treated as missing signatures, which I think is what we want, then you do need a way to get to the warning again. And the way to get to the warning is to be able to turn on this expectation. That's the rationale for this draft.
Okay, so I think you either need to go to LAMPS, sorry, or a BOF. I don't know, but I think a BOF's going to send you back to LAMPS anyway, because I don't know there's anywhere else to go. I'm sorry. So I think the easy path is to take you to lamps and be done with it. The hard path is to take you to a BOF. I think you can do the broken missing signature thing by using.
The broken missing signature thing is already in a document that is hopefully on the way out the door of lamps.
I mean, I
which
can
is
do
the
that with a signature block, right? I can add to my signature block, by the way, all my messages should be signed. And if you get an unsigned message, you can say, what the hell?
But the
I mean,
user agent can't interpret that.
No, no, you have to have the people.
Right.
do
So
it,
we need
and
the
people
signal.
aren't
So
gonna
we
do it.
need to have the signal for the user agent to be able to make this decision.
Right, because you're,
Okay.
like, your everyday people aren't going to do this.
Sorry, we need to move on. AJ.
Hi, AJ, work at NIST, but this is more as an individual thing. I'm relatively new to IETF. I had some reactions to what Philip said. I don't disagree, but even if SMTP is on the way out for commerce, oftentimes I have accounts for services, whether I like them to be attached to my email address or not is really not a choice I get to make. It's something I have to live with. And I think it's something we all have to live with. And it might not be the exact implied use case for this problem, but there are other adjacent use cases where I see there's value to this, at least for me at a personal level. I don't know if it belongs in a redispatch to be funny about it or going to a BOF, but I'll follow on, and I actually find this work interesting. Like, I would be interested in it. That's it. Thank you.
Thanks.
Okay, thank you. Yeah, okay, so we've heard kind of buff lamps. So maybe, Roman, do you wanna jump in?
Yeah, I don't have the mythical answer. I will repeat
Yeah,
what
yeah.
you said. I heard a little bit of lamps. I heard kind of BOF, and I also feel like, and I'm injecting myself and kind of Paul here, I feel like this has some overlap with email in general. So I would want to make this decision a little bit in consultation with the critical mass around email working groups, aka in ART, to kind of give us some direction here as well.
And the other piece was liaise with MOG, because they have
yes.
the UI, the folks who are doing some of the major user agent.
Right.
UI
So
work.
yeah. So bottom line, I don't think we have something kind of clean here. Why don't we talk with Art and figure out how
Yeah.
we could do this jointly, or figure out kind of the next step. Thanks.
Yeah, thanks, Roman. Good. Yeah, no worries. No, it doesn't work.
Hello, everyone. I'm Lin Zhili from Zhongguancun Laboratory. The topic of our draft is sub-based anti-DDoS architecture. The short name is sub-D. Next slide, please. Here is the outline of our presentation. First of all, we will do the problem statement, and then we will introduce the architecture and the workflow and the transmission of sub-D, and then we will illustrate the advantages of our architecture. Next, please. So spoofing source address is one of the common technique used in DDoS attacks. All of the reflection or amplification DDoS attacks and a part of the flooding DDoS attacks use this technique. To defend these two types of DDoS attack, the defense position can be divided into two main camps. One of the position is near the target set. The other is at the middleware of the networks, which indicates the net operators. So the defense system near the target set will do often do full flow detection to detect the attacks, and then diversion and diversion the traffic, the attack traffic to a certain cleaning device, and then the traffic will be re-injected to the network. So the weaknesses is that the defense capabilities is limited by the bandwidth and the cleaning capacity of the defense system. For the other position, the middleware networks, because of the large scale of the flow, then they use net flow based sampling analyze to do attack detection, but the sampling mechanism always bring some weaknesses. One of the weaknesses is because of the sampling mechanism, the accuracy of the the accuracy of the attack detection is not very high, and it will always cost several times to do several minutes to do the attack detection, and also because the continuously sampling, it will cost much. So the idea came to our mind is, can we find the attack packets at the source? So we noticed the sub. This is a source address validation technique that can detect packets with spoofed source address. Sub devices will use a table to record the IP passing it and passing through it. So if the packet with the IP is not matched the table, the device will drop it. So it sounds very useful, but because of the high cost of the deployment, the sub devices is not deployed very much. Next, please. So from this picture, we want to introduce the capability of sub. If the sub device is deployed at the assigned network, it can achieve the detecting of the host granularity. If the devices are deployed at the interdomain, it can achieve the detecting of IP prefix granularity. For interdomain, it can achieve the AS address segment granularity defense. So we can see that if we want to achieve effective DDoS defense, we need a large we need a high rate of self-deployment. And for the reality, as the development rate is not very high today. So when self-development scales are limited, the attacks still exist in non-deployed areas. Next, please. So we also want to introduce the packet handling mechanism of sub. Nowadays, the sub device will directly drop the packets with the spoofing source address packets. So this behavior brings some disadvantages. One of the disadvantages is in large-scale attacks, the bots are widely distributed. So if we drop the packets directly, the effect of it will only effective at the network which employed the sub. And if the sub device is continuously dropping the packets, there is a possibility that the bots will migrate to a non-sub deployment area. So our idea is during the incremental self-development, the information uploading should be prioritized instead of direct dropping it. Next, please. So this is the architecture we proposed. For the sub devices, they can get some of the information of the spoofing source address packets, and it will send it to the sub-D controller. The controller can detect DDoS attack, use this kind of information and then generate the roles, maintain an IP blacklist, and then issue the roles to the sub devices or non-sub devices or even the victims defense systems. Next, please. From this specific example, we want to introduce our workflow of sub-D. Here's the red lines indicates the attack traffic, and the attackers use the zombie bots 1, bot 2, to send a request for spoofed source address to the reflection server, and then the reflection server will reflect the flow to the victim. So in our architecture, the sub devices will record the message information of spoofed source address and then report it to the sub controller, and then the controller can aggregate and analyze the information calculated from the sub devices and detect whether DDoS attack occurred. Next, please. In the third step, the based on the attack detection results, the sub-D controller can generate the specific filtering rules and issue them to the sub device or non-sub device or even the victim defense systems, and the whole and the security devices in the whole work can get the benefits. Next, please. Except for the DDoS detection, we also think that the sub-D architecture can be employed as a security intelligence exchange system. The Sava routers who do not drop the spoof source IP packets can be considered as a honeypot. And the network deployed with sub can be seen as a honeynet. So the honeynet can gathering and report the spoof source address messages to the controller, and the controller can generate some security intelligence and then send it to the security system or the devices in the whole network. Next, please. From in our architecture, there are lots of information need to transfer. So in this page, we want to say that from the sub devices to the sub-D controller, there are maybe some monitoring messages should be transferred. Such as the source or destination IP or port numbers, and the message length or the time span of the packets. From the sub-D controller to the other devices, there are two kinds of information should be transferred. One is the filtering rules. It can be the ACL rules or the IP blacklist. And also the other can is the threat information. That can be the attack detection results or the other kinds of security intelligence. Next, please. So there, we want to emphasize the advantages of our architecture. First of all, from this architecture, we want to achieve more accurate detection of DDoS attack, and also in field sub devices development scenarios, we want to make full use of spoofed source address packets to leverage an advantage of sub and enhance the revenue of sub deployers. Next, we will implement the sub-D to show its effectiveness. And also, we are looking for the cause of this draft. So if anybody interested in, or if anybody is interested in our work, please contact me anytime. Thank you.
So are you asking a dispatch question here, or is like, okay. So do you have something in mind, or?
We noticed that DDoS open thread signaling. The transmission in this architecture can use dots, but it is concluded now. So.
Okay. Anybody? I don't see anybody in the queue. So anybody has any thoughts about this? Richard.
Since nobody else had any thoughts, I'll come on screen and ramble a little bit. I mean, it seems like there's a few things that need to be the case for this scheme to be useful. It seems like you need to have, as you said, a sufficient density of SAV domains out there, but also for this to be useful, for the SAV information to be useful for detection and response, you need to have sufficient density of the attack traffic in those domains to be able to take action on it. So I'm not sure that either of those is actually true at this point, and so it seems perhaps a little premature to do work in this domain.
Okay, the sub device is actually not deployed at the attack targets network. It is deployed at the zombie boats network. So it can block the attack at the source of it. So It can attach. It only can share the information to the victim's web devices.
Yeah, what I meant about density is that it seems like the way one tends to respond to this is not to block, say, individual IP addresses, highly attested though they may be, but to block prefixes or networks. And so even if you get high quality information that a certain IP address is involved in this DDoS, unless there's a sufficient density of other hosts in that network, you're not really going to be able to quelch, to block traffic on a scale that would affect the DOS, unless you have a bunch of participants in that network.
Yes, that's true.
So not only do you need a bunch of SAV networks, you need the especially bad networks out there to be SAV networks.
Okay, we were thinking it later.
Okay, Ben.
Hi. So I think that to move forward with this, to me, the thing that I would really need is a clear, realistic use case where the existing DOTS specifications don't suffice. And I can sort of understand the value of for anti-DDoS work of having cooperating sampling points across the network that could help you get a better understanding of where traffic is really coming from. Yeah. But I think we would need to lay out a pretty clear attack scenario that represents something that's actually happening and is and again, it isn't already covered within the DOTS framework.
Okay.
The other thing that I want to point out here is that if you are building widely, you are building a pervasive passive monitor.
You're breaking up, Ben. Oh, this thing? Okay. I see him still here. Okay. Let's give him a minute. Anybody else?
He's back.
Is he? Ben, try again. You're on mute.
Hello? Okay.
Yep.
Yeah.
So the other thing is, building large-scale passive network sampling systems is useful for preventing DDoS attacks. It's also a large-scale pervasive passive monitoring system, which we've explicitly declared is an attack against the internet. So before we start building systems like that, I think we need to actually check whether that's essentially permissible within our view of security.
Yeah. Thank you for your comment, and we will propose a clearly use case next time.
Okay, it seems that there's a need for more discussion, like there is no way to dispatch it at this stage. So let's have those discussions and then see if there's interest and see how we can work on it in the future. Okay, 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 thank you. Okay, yeah. Okay, we have about an extra 10 minutes here. Any other business? We'll give you back 10 minutes then. Oh, go ahead. Hold on. Yeah. Justin.
Hi, sorry, I forgot to jump in the queue. Just because they didn't let me present at the last IETF, I wanted to let folks know that the Whimsy is having a BOF tomorrow morning for workload, identity, and multi-system environments. Tomorrow morning. It might actually just be after lunch. I forget. It's tomorrow. So if you are interested in the workload identities, especially the identity chaining type of stuff that was in the first presentation, please join us at the Whimsy Boff. It's going to be a good conversation. Thank you.
That's Wednesday at 10 a.m. Oh, tomorrow?
Tomorrow.
This is the side meeting?
No.
Oh,
Buff,
sorry.
Buff. Okay. It's a buff. Okay. Any other business? Okay. Thank you all. No worries. I didn't look at it, but I assume you know what you're doing, so. I should. Yeah, sometimes. It's good to.